Solving a quadratic equation usually means finding all values of x, or whatever the variable is, that will make the whole polynomial equal 0. To do this, we're going to use something called the zero product property. And the zero product property says that when you multiply two things together, if their product is equal to 0, then either A has to equal 0, B has to equal 0, or A and B both equal 0. This is because when you multiply something by 0, no matter what the other thing is, you always get 0. And there are no two non-zero numbers that you can multiply together to get 0. So one of these, at least, or maybe both of them, have to be equal to 0. When we apply that to quadratic equations or polynomials, it means that if we have a factored polynomial, and this whole thing is equal to 0, then it means that at least one of the three factors, the three things we're multiplying together here, because these are all factors, one of these things at least is going to be equal to 0. So to figure out what values of x will make those equal to 0, I'm just going to set each one equal to 0 and solve for x. So I'm going to take my first factor, which is x plus 2, set it equal to 0, and then solve. So I'm just going to subtract 2 over, and I'm going to get x equals negative 2. That means that if I substitute negative 2 back in for x to my problem here, negative 2 plus 2 is going to be 0. This whole term will become 0, which means that when I multiply it all out, I'm going to get 0 times x minus 3 times x, and 0 times anything is going to give me 0. So now I need to set the second factor equal to 0 and solve for x, because negative 2 isn't the only value that if I plugged in for x would give me 0 here. If I have x minus 3 equal to 0, I'm going to add 3, and I will get x equals positive 3. And lastly, I have a factor that is just x. So if I set that factor equal to 0, it's already solved for x, which means the three numbers that I could possibly have for x that would give me 0 for this polynomial are negative 2, 3, and 0, which means the solutions to this equation are negative 2, positive 3, and 0. If we ever start with a polynomial that is not yet broken down into its factors, for example, 3x squared plus 4x, and we want to solve this. Note, we can't solve a polynomial if there isn't an equation, right? Solving means finding an x that makes the equation true. So to solve a polynomial equation, there needs to be an equal sign for it to actually be an equation first. In order to start solving this example, the first thing we have to do is figure out what the factors are. So we're going to factor this polynomial. I see a GCF here, a greatest common factor, because both of my pieces have an x in common. So if I take an x out of both of these pieces and factor it out of my equation, I'm not going to get rid of that x. I'm just going to put it in front because that is a factor still. What do I have left? 3x squared divided by x is 3x, plus 4x divided by x is 4. Now this is fully factored. I don't have any higher powers of x than just 1. So I am now going to proceed with solving this. So I have two factors. I have x, and I have 3x plus 4. I'm going to set each one equal to 0. x equals 0. That's already solved for x, so that's one of my solutions. 3x plus 4 equals 0. I'm going to have to solve for x. So minus 4, 3x equals negative 4, and then we're going to divide by 3 to get x equals negative 4/3. So the solutions to this equation are x equals 0 and x equals negative 4/3. If you want to check to make sure that you found all of the solutions, the number of solutions you end up with should be the same as the degree of the function. The degree of a function is the highest power of x in the polynomial. So my degree of this function is 2, so I have 2 solutions. There are occasionally examples where you will end up with slightly fewer solutions than your degree, and that's because one or more of the solutions are actually a double root, a double solution, meaning they count twice. So really, you should have the number of solutions is going to be less than or equal to the degree of your function. Let's do another example. X squared minus 16x equals 80. So I want to factor this polynomial, but before I can factor it, the whole polynomial needs to be equal to, set equal to 0. So I'm going to subtract 80 from both sides so that I end up with a polynomial set equal to 0. Now I can factor this. So I'm going to get x times, this will work out to not 8 and 10, it's going to be 20 and 4. X minus 20 times x plus 4. That's how that trinomial would factor out, and that's going to be equal to 0. Now I have two factors. I have an x minus 20 and I have an x plus 4. So I'm going to set each one equal to 0. And solve for x. So I end up with two solutions. X can equal 20 or x can equal negative 4. And again, I should have less than or equal to the number of the number of solutions should be less than or equal to the degree. Here we have two solutions. We have a degree of 2.